Okay, we'll go ahead and get started. Today's conversation is being recorded, and we'd like to start by thanking all of you for joining us for this panel discussion on how to modernize mainframe data access. My name is Jeannie Glass, and I'm founder and CEO at VirtualZ Computing, and I'm honored to moderate today's panel discussion. We have several industry experts and influencers with us today, including Ashish Khandelwal, mainframe modernization engineer with the Azure database team at Microsoft, helping customers adopt Azure data services, and Steve Reed, global black belt in mainframe modernization at Microsoft, helping customers ensure their legacy workloads perform as fast as possible and are resilient and highly available. Steve and Ashish, thank you so much for joining us. We really enjoy working with you and appreciate your partnership at Microsoft. Vince Ray is CTO at VirtualZ. He's a patented mainframe software innovator whose vision was behind most of the products now held by Broadcom, and he leads development of our revolutionary data access solutions. Dustin Freum is CFO at VirtualZ. He's a recognized authority in technology provisioning, pricing, license governance, and contract negotiations. So thank you all for joining us on the panel today to share your expertise and insights in the area of modern data access. Also, just want to point out that the chat is open throughout the session today for comments and Q&A, and we will open up the conversation to addressing the Q&A questions in the chat at the end of the conversation. So also we can go to the next slide. We thought we'd first start with discussing the problems that customers are facing with legacy data access methods. Today, customers have thousands of applications running on cloud and distributed platforms, yet the majority of business critical data resides on the mainframe. And on the next slide, customers are increasingly moving applications from the mainframe to cloud and distributed platforms. So the demand for data access is skyrocketing, and the cost and complexity of legacy lift and shift methods, which require coding, manually capturing and transferring terabytes of data across your network once a day, once a week, once a month, based on individual application requirements, those costs and that complexity is skyrocketing as well. And legacy methods also result in multiple copies of your sensitive business data that's immediately out of date and out of sync the minute it's extracted is being used to run your business. So Steve, let's start with you. Why do you think data access is so important for application modernization customers at Microsoft?
Great, thank you, Jeannie. Yeah, I actually, two things come to mind for me in my travels in helping folks modernize their legacy systems. The first is you have to realize that when you're going to modernize any legacy system, you're going to have 1 foot in two worlds, 1 foot in the legacy world and 1 foot in the cloud world, and the hopefully Azure cloud world. And during that time period, when you do have that, then you're going to have applications in the cloud that have access to the mainframe and vice versa. And so that's why it's, I mean, unless you have that, you really can't really entertain a true modernization journey. The other thing is that a lot of folks still have their core mission critical core applications on the mainframe, and what they want to do is they want to take a lot of the applications that we would probably all argue should not be there in the first place. These are the modern payment applications and things like that, especially in FinServe, where they want to put them out so they can hyper evolve out in maybe like a Kafka architecture or something like that. But they're still going to need to have access to that mission critical sole source of truth data on the mainframe. And so that's why it's critical that we can have something like Lozen that allows that to happen.
Great, thank you so much, Steve. On the next slide, Vince, we recently commissioned a study by IDC, as you know, to give us a better feel for what customers are saying from an independent third-party perspective. And 44% of customers say that they have applications that they would like to re-platform, but they can't. And some of the main reasons they can't are related to the data residing on the mainframe. And there's a lot of complexities around that and why that is. Vince, what's your view of the challenges that customers are facing and why this chart looks the way it does?
Yeah, and there are many issues here. One of the kind of core challenges here is that mainframe data is a little bit different than data that you find anywhere else. The capabilities of, let's say, something like VSAM just don't exist in other platforms. So it's not really just a matter of how do I connect to my mainframe data and process it in a different way. It's also that mainframe data is capable of doing a lot of things that are just very different than what you see in other environments. And so because of that, you see folks doing all of the things listed on the slide here. Probably the most common thing is, because it's difficult to get at the data directly, folks develop APIs or custom code that allows you to access your mainframe data. There creates so much complexity and such a kind of brittle and fragile environment. It can be a real inhibitor. You also find, and I won't spend a lot of time going through all of the others of these, but that data is probably locked and has dependencies in many applications. So you may be interested in getting that data into an application that you want to move to the cloud, but there might be 20 other applications that for whatever reason just don't justify being moved to the cloud. So now you've got that issue of how do I get the data I need where it needs to be processed, keeping in mind that other things on your mainframe are still going to be dependent on it. So not breaking those dependencies is a really critical thing. And again, you add things like we saw on the previous slide about what amount to replicating that data, FTPing it or copying it and so forth. And now you've got a whole new set of challenges around how do I keep it all synchronized? How do I make updates to that data from the distributed platform that now need to go back to my mainframe, understanding that some other application may have come along and changed that mainframe data. All of these create very difficult problems to solve, and it's really why we looked at it as there needs to be a better way for most of these things.
Thank you, Vince. The shared data, either indefinitely or even temporarily, is obviously one of the main issues that customers are facing, as you said. Steve, going to the next slide on the techniques that are used for accessing mainframe data today. What is your view of these legacy techniques that customers have been using up until now? And why is there a need for more modern solutions?
Let me come off of mute. I would piggyback on top of what Vince said. I think that, in my travels, I've seen Lord knows there's been a lot of API creation, and in CDC is probably one of the most used tools in a legacy migration effort. And I think that now with something like Lozen, we can look at those and go, well, those were actually really good, and they got us to where we, back in the day where we wanted to go. But now we have a new way of doing this, which I do think is sort of a breakthrough of sorts. And so it addresses a lot of these, and it's really going to, I think, make people take a second look at how they approach this.
Great, thank you. Ashish, as part of the data engineering team at Microsoft, what are you seeing as far as the biggest challenges customers are facing with data modernization?
Yeah, now I'm off mute. Okay, so one of the biggest challenge faced by the customer is as part of their ETL process. the data present on the mainframe is not exactly the data present on the distributed side. So as I'll tie it back to what Vince mentioned, like data might be in EBCDIC format also on the distributed side, it could be in UTF-8 or ASCII format. Another thing is, as soon as you extract the data from the source system, there is always a CRUD operation, or always some operation going on the mainframe side. So when you extract the data with the means of ETL process, your data is not the real-time data. Hence, whatever the reporting or analytic customer wants to run on that data, it's not happening with real-time data. It's happening on the stale data. I think with the help of this, Lozen software from VirtualZ, it will be easier for our customer to directly read data from the mainframe file system and perform near real time reporting and analytics on that data, if not the real time. Also, with this solution, the customer can eliminate whole cost of ETL. ETL is like very costly process. We need to maintain different source of data, etc., etc. So that cost of ETL and CDC will be eliminated by this VirtualZ software. Over to you.
Thank you, Ashish. Vince, on the next slide, could you briefly describe Lozen to our listeners and explain how it will help them and their customers modernize mainframe data access?
Yeah, Lozen is very simple to understand. We install a server process that executes on your mainframe, and as a footnote, one of the cool things about Lozen is it's engineered to exploit IBM Z processors. So basically, it's a very low-cost option to run on your mainframe. And what it does is it provides access to all of the type of files that you see on the slide. Really, it's an open-ended list of files. These are the ones that we started with in our first product release. But the idea is a little deeper than that. It's not just here's access to vSAM. It's all of the capabilities of vSAM. So if you have an application that you want to, needs to open a vSAM file and retrieve a record by its key, you absolutely can do that through Lozen. Now, on the client side, it's actually also very simple. We'll talk about this in a subsequent slide. But the footprint of Lozen is very, very thin on the client. We rely on industry standards like the NFS protocol that allow us to run with very, very little software on the client side. So pretty much any application, whether it's on-prem in your own data center or in the cloud, or really any type of application, can request Lozen services and access vSAM files, sequential files, and so forth from your mainframe. The key is that there's only one copy of the data, so the data remains on the mainframe where it's fully secured by all the access control policies and procedures and management tools and so forth that the customer has always had. And it's very, very, very high performance. It's very it's always accessing live data, because it's not like we're making a copy of your vSAM file. You're operating against the actual live data.
Great, thank you, Vince. And on the next slide, can you walk through Lozen's integrations?
Yeah, and I hinted at this on the previous slide. There are a few different ways that you can access Lozen. Certainly the simplest is what you see at the top, native NFS. So if you have pretty much any platform that has a built-in NFS capability, and that includes Windows and Linux and Mac OS and pretty much every platform, you can reference your mainframe data as though they're just local files on whatever system you're running on. And as I said, it's not just sequential access. All of the capabilities of the underlying mainframe file system are available to you there. So if you need to, open a file and read it backwards, you absolutely can do that with nothing more than the native NFS support. On top of that, there are a couple of, I'll call them application environments that we wanted to integrate with just to make the transition much simpler for our customers. A good example is the work we've done with our friends at Micro Focus. In that case, if you take, let's say a mainframe COBOL or PL1 application, run it in the Micro Focus runtime, it runs completely unchanged and accesses the same mainframe data that it's always accessed by going through Lozen's Micro Focus connector. It allows you to move applications with really nothing more than just recompiling them in the Micro Focus environment. For some of our customers that are doing, I'll call it, I don't know, lower level things than that, we also give you a Lozen specific API. So if you're writing, let's say a C program or a Java application, and you want to access mainframe data, instead of really understanding how to do that over the native protocol, we make it much simpler for you. So you'll see methods in there like, fetch a record by its key or by a relative record number, or, open and read backwards, or, insert a record or delete a record, all of the things that are very common on the mainframe, not so common in other platforms. So that's available really for any application developer that wants to do custom programming at a low level against Lozen. And then finally, really the two on the bottom are similar. There are, I tend to call them integration hub applications out there. An example would be Microsoft's Azure Logic apps, or there are many of them from TIBCO, Boomi, IBM, many others. And what we've done is we've wanted to have a kind of drop dead simple way to integrate Lozen within those contexts. So if I'm in MuleSoft, for instance, designing a pipeline that's going to access some mainframe data, it really is a zero code approach. You just drag and drop the Lozen object into that flow diagram, and through just some configuration parameters, you can specify, what data do you want, what operation do you want to perform against it? Do you need to fetch records, update records, and so forth. And all of that is available to you in a familiar environment, so you don't have to know very much about Lozen to use it that way. Ultimately, it all works the same way. It all connects to the same Lozen server. It's got all the same benefits I talked about in terms of security and management and so forth. It's just, our goal is to make it as easy as possible to get to that mainframe data, no matter what type of application you might have. And that's why you see multiple options here.
Great, thank you, Vince. Ashish, how do you see downstream data from the mainframe being accessed either for integration or coexistence with applications moved to Azure?
Yeah, so that's a great question, and often customer ask us, okay, you have the product, how you can integrate this with Microsoft technologies, right? So Vince talked about Micro Focus connector, native NFS. I'm going to talk about Lozen API. So what you can do is and open API. So what you can do is there are various services available in Azure which you can integrate with Lozen. So for example, Azure Functions are there, Data Factory is there. However, I would my preferred choice will be the Logic app. It's kind of like low code, no code service in Azure, provided by Azure. And with Logic apps, you can customers can automate their workflows and integrate their data as well as application. This service is a highly scalable solution, and we already have an existing connector within this service, which can connect to customers' IBM MQs, their DB2 system. So I think with this approach, applications in Azure can read, write data from mainframe using a Lozen solution. So my preferred choice will be Azure Logic apps. Over to you, Ginny.
Great, thank you. Steve, before we move on to the next solution we're going to discuss today, What benefits do you think customers who are modernizing to Azure will gain at large from Lozen?
Yeah, great question, Jeannie. I guess what's happening now is a lot of folks are realizing that there are some definite benefits to cloud architectures, and there are some applications that are on their mainframes that probably should not be there, and that they can benefit from scale, elastic scale, and things like that. And so a lot of these and just the sheer nature of how fast these applications evolve, because we want to respond to customer demand and things like that. And so a lot of these applications are very complex. And what you can do, the traditional method was let's create an environment, use change data capture, and we'll pump a lot of the mainframe data, the VCM data out into some kind of an environment. We'll stand up these applications, but what they inevitably always find out is that at some point they're going to need read and write access back to that VCM data, and that really is at the heart of what I see the value add on top of what Lozen provides, because now we can actually have those applications. They can be in whatever environment we want them to be in the Azure cloud, but they can also have the read-write access back to the mainframe mission critical data, which they're going to need. And I think moving forward, that's going to streamline a lot of the application modernization efforts.
For sure. Thank you so much. So Vince, on the next slide, Lozen is available today. So install Lozen today and achieve all those benefits that Steve just talked about. But we have a second solution coming to market this fall called Zaac. We've been working with Ashish and Steve and the team at Microsoft as subject matter experts on Zaac as well, which really delivers the reverse of Lozen. But could you describe Zaac, Vince, and how this will augment or add on to Lozen?
Oh, sure. So the way we think about Lozen is that it's mainframe data being shared with applications that are not on the mainframe, whether they're cloud or anywhere else. Zaac really kind of completes that circle. Zaac is about mainframe applications that need to access data that's not on the mainframe, so cloud data in Azure or really any cloud data source. So, and that's exactly what Zaac provides. It provides really any mainframe application with a way through nothing more than a simple JCL change to reference data that's maybe cloud data, maybe it's on-prem data, but it's certainly not mainframe data. So if I want to change a mainframe application to read and write files in Microsoft Azure, for instance, as I said, it's really just a matter of a small JCL change. So, there are a number of different important use cases here. We've heard examples from customers where they're trying to do, they're generating whatever information, reports and so forth on their mainframe that they want to share with employees. One approach we've heard about is they write that information into the Dropbox accounts of potentially thousands of different employees. Well, today that's hard to do. Today you'd either have to write a lot of custom code and figure out Dropbox APIs and make all of that work on the mainframe, or you probably will do it in kind of an intermediate multi-step path, where you create a bunch of information and then you run a whole bunch of utilities off of the mainframe to move it from one place into another, where you ultimately want it to land. With Zaac, all of that will be unnecessary. You just run your application that's generating whatever data you need to get into some cloud source, and the rest is pretty much automated for you. The same is true going in the other direction. Many customers have applications from running all over the place. It could be SaaS applications like Salesforce or Workday. It could be custom things that they've developed in the Azure environment. Well, a lot of those applications are generating data that ultimately needs to find its way back into the mainframe. So Zaac gives mainframe applications a very simple, very direct way of reading and writing that data as well. So, it completes that circle where you can go in both directions now. With Lozen, it's mainframe data shared with other platforms. With Zaac, it's other data being shared with mainframe applications. One interesting side effect of this is that as part of Zaac, we're also targeting connecting to a certain class of physical devices. And I think of them as low cost, very capable storage devices that traditionally have been really hard to physically connect to a mainframe. With Zaac, I'll be able to take something like, a quantum device or a NetApp device that I might have sitting in my data center, and I'll be able to access it using the iSCSI protocol. As though it were just another local mainframe device. So, again, it opens up the possibility to use these new generations of devices with mainframe applications and get the benefits of low cost, scalability, and so forth. So it lets you do everything from kind of burst into cloud environments like Azure to exploiting new devices to connecting to SaaS and other kinds of applications. So we're pretty excited about Zaac. We think together Zaac and Lozen give you the flexibility to get data wherever you need it in a bidirectional way, no matter where you want to store it. You want to store, I don't know, let's say your mainframe test data in a cloud environment to save a little bit of storage cost. Absolutely, you'll be able to do that. So yeah, we think there are tons of use cases here, especially with Zaac and Lozen together, that make this a really, really powerful story.
Thank you, Vince. Ashish, as you know, we truly appreciate our partnership with Microsoft and the subject matter expertise that you and Steve and your teams provide. But what is it that Microsoft finds compelling about Lozen and coming soon, Zaac, now, for mainframe data access for Azure customers?
So mainframe customers, they have their data spread across various data tiers, so such as like RDBMS, DB2, right? Then file system, like Vince mentioned, vSAM, GDG, and sometimes network hierarchical or network databases. Okay. What customers are looking for is the right solution to perform data virtualization across different data sources, not just one. So like for DB2, you can go with ODBC, JDBC kind of connector, and bingo, you can connect to legacy sources. But what about the file system? So they have to then turn around to the different solution. So what they're looking for is one single solution which can have them access with different data tiers. So what I think is like Lozen and Zaac, they provide the right capability to read a data file directly from mainframe without them being transferred onto distributed platforms. So this is upper hand, I would say, because when it comes to data files, they could be having millions and millions of records. We don't want them. We just want whatever change. So we just want to extract the changes. So this reduces the cost of data transfer and provides access to real-time data for our customers. So I would so this is what I like about Lozen and Zaac is like it's a low cost, easy to access for mainframe data file directly from mainframe to Azure, and it also improves the speed of mainframe application modernization to Azure. Over to you, Ginny.
Great, thank you, Ashish. We appreciate that. Vince, one of the most common questions that we receive is about latency. What should our listeners know about Lozen and latency?
Yeah, so, and absolutely, I totally agree with that. I mean, it's certainly a question that comes up every time we speak. So, the thing to understand is, first of all, Lozen and Zaac benefit quite a bit from the industry standard protocols that we rely on. If you were to look at the protocol across the actual network connection, it's you'd see things like NFS, and NFS is one of those things that's been around for decades. It's been through generations of development, and the current versions are actually quite good at what they do. And what that means is you get the benefit of compression and caching and on and on and on and on that way. And we get many of those benefits as well with Lozen. So there's certainly no magic in the world. Ultimately the amount of throughput you see is going to be a function of network bandwidth and latency and so forth. But and working with our friends at Microsoft, we're starting to understand that especially larger organizations have so many different options there for throughput and dedicated bandwidth between cloud data centers and your own data center. It's pretty much possible to achieve whatever level of throughput that you want. Just to put a real stake in the ground as to what I'm talking about there, and you guys are welcome to read the details in a blog post we published recently. But we took Lozen to what I'm going to call a real mainframe, a Z15 class mainframe with multiple zip processors and fairly high-end networking, and we connected it to a client application running on nothing more than a Linux application running on an Intel x86 server, and we were able to, without really more than a couple of hours of juggling with it, we were able to achieve almost 90% of native throughput working in that environment, even though it was being accessed remotely. And so I don't imagine that any large mainframe site would have any trouble getting whatever level of throughput that's needed for the type of application that's wanted. The other thing also is that a lot of scenarios, like let's say you have a big sequence of batch processes that you move to the cloud, and they're running one after the next in sequence. Well, the type of caching we do will generally cause that data transfer to be happening the first time the record is referenced, and from there forward, that data exists either in memory or in the local file system in the cloud. Full integrity is provided, so that record gets updated somewhere. Absolutely, we know about that, but what it means is you're not over and over and over again moving that same data back and forth, and that's really an important thing as well. And then finally, the other thing that's really important to understand is that if you're starting from a place where you're doing something like an ETL application, transferring an entire file, processing against that file, and then maybe transferring results back to the mainframe, you understand that with Lozen, if that file happens to be, let's say it's a keyed VSAM file, you might just read and write a small subset of the records. You may be doing like, go look up this record in the keyed VSAM file. With Lozen, that's only going to result in one record being transferred, not potentially terabytes in the entire file. So for all of these reasons, I guess the good news is there are so many things that can be done to get whatever level of performance that you want. The bad news is it can be complicated, and you really need to understand the characteristics of your application. But we're certainly here to help with that and to make recommendations as you deploy. Back to you, Jeannie.
Great, thank you. The first question is, this will see the other downstream apps / distributed systems to build their own, or this will need the other downstream apps / distributed systems to build their own small app or logic for the data they are accessing directly from the mainframe, which otherwise they already build for file-based data. How do you explain that?
Gee, I'm not sure I understand the the question in that case. I mean, there are, you know, certainly, and a feature we haven't really touched on yet is that, you know, Lozen includes data transformation capability. So, you know, some of those are really very simple cases, like, you know, Ashish brought up the ASCII to EBCDIC cases and so forth. Those are really simple cases. But you can do complicated things with data transformation as well. An example that we use internally sometimes is I can take a complicated VSAM file, and you know the records are, you know, typical to what you find in a mainframe application. You know, they might have some text data, some binary data, some packed decimal, some, you know, arrays and so forth. Yeah, and we can transform that into something like a CSV file. And once it's in a CSV file, I can actually open that with something like Microsoft Excel and process that VSAM file as though it were a spreadsheet. There's no intermediate application. And in that case, there's exactly zero code of VirtualZ on the client side. You know, all you're doing is running out of the box, you know, Microsoft Excel in this case, and relying on things like data transformation. So, you know, that would be, you know, one example. And of course, the data transformation is totally open-ended. You could, you know, instead of my CSV example, you might transform that XML or that record into XML, you know, or JSON, or, you know, whatever your application needs to see. That's kind of our goal, is to give you the data that you want in the format that you want to process it in, so that you don't have to do the type of, you know, transformation in a, you know, coded application the way the question was described. So, you know, I'll apologize in advance if I didn't really get the gist of the question, but I think you'd find out that that's a pretty simple thing to do.
It sounds like from the chat, Vince, that maybe the question has more depth than can be typed. So Elsa is going to see if we can unmute one of our guests. I'm not sure of the answer, but if not, if we can't unmute you, please reach out to us after the call, and we can set up time for you to talk with Vince directly. Oh, wait. I guess that's the same. Great. Welcome.
I think I can speak. So my question basically was, so for example, we have a lot of legacy applications, and one of the application, let's say data warehousing, okay, and they are using Talent tool to, you know, extract the data. So what what I wanted to ask is, currently they are accessing our files directly. I mean to say, we have a different file transfer systems to transfer the file to distributed systems, and as somebody rightly said, most of the application may not be using all the data in the file, and some of the applications are using the data, but they have to modify that basically data, not only in terms of, as you said, the com3 com2 variable. Even after doing that, they might have built their logic, their application based on what they need. Okay, now what I'm trying to understand here is, let's say you have this capability, and let's say the other system has the capability to access the mainframe data directly. Now they might have the data or the field to know like what to access, and probably you are also providing the conversion mechanism where they don't need to worry about the com3 and com2 variables. But even after that, they still have to write their own logic, their kind of separate small application to do the same thing which they were already doing it. So now my question is, even at one place you're solving one like problem for the mainframe thing, but a lot of distributed application, why they want to put their money to know just to take care of this advantage? Because they must be thinking, I already put a lot of money and a lot of effort to customize my application based on the file got from mainframe. Now if you are using some kind of, I mean to say, giving some kind of facility where they don't need to code, you are just providing a ready-made solution, probably they might be able to think it, but I'm not understanding if they can use it directly without, you know, doing anything. I'm sure I'm trying to elaborate my question better.
Yeah, no, so first of all, I think you're 100% correct that sometimes there are applications that attach, I'll call it business logic to data formats. You know, so the the data is not just read and written in kind of a native form. It includes things like, calculated results that are part of the data. It's business logic. And I agree 100% with your observation. If you're moving that application to, some other environment, then that processing done by that business logic needs to be replicated as well. However you want to do that. And a lot of customers are looking to do that in a zero change kind of way, and that would suggest something like the microfocus approach that I talked about, assuming it's COBOL or some easily available language that way. But these days, a lot of folks are also doing those things with products like Mule or Logic Apps or in the Microsoft stack, or many other products there. So I think you would want to do a deep dive on what do I want that architecture to look like on the distributed side, and make some choices there. The bottom line, though, is that you do have the same level of access to the underlying data no matter where your application is running. So whatever choices you make, Lozen's able to give you that connection to the data with security and integrity and so forth. So you're kind of free to choose whatever you want for that business logic side of it.
But I think they still need to decide, like, because they also have to pay for the Lozen software, as well as whatever, if they need to tweak at their side, the logic and things. For that also they need to buy some product or whatever it is. So they need to see like whether the new things are giving benefit and what they're already paying with their own set of applications, right?
Yeah, I mean, and again, it depends on the choices that you make there. A lot of folks these days might choose to do that business logic part in, let's say Java. And in that case, there's not necessarily a vendor product there. That's just, rethinking whatever that logic is in Java. And, again, there are plenty of applications and plenty of folks at places like Microsoft that will be able to help with that.
Sure. Thank you.
Thank you.
Yeah, thank you for the question. So Vince, I just want to finish on the data transformation side. In the chat, we have a question. Lozen can read EBCDIC data and convert them as readable format, or just read and store as is?
Yeah, so I described the data transformation that we do a little bit before. I mean, it is on both the read side and the write side. So the idea is that what's physically stored in the file generally doesn't change, but the application's view can be whatever it wants to, and that's true whether it's just reading data or generating data, writing data. Another important feature there is that often the most difficult part of data transformation is understanding the layout of the records that you've got. So one of the features we've built into our data transformation is that if you've got something like a, let's say a COBOL copybook that describes your records, you can point us to that. And once we understand what the underlying layout of your records are in the file, we can use that to automatically generate the transformations that are needed. It's much more than ASCII and EBCDIC also. Packed decimal, floating point. The mainframe has some unique data formats for some of these things, and they can be, pretty much all universally understood. It's even possible to do custom data formats. So an example of that might be you might have, let's say a bunch of text that you want to present to another application as a PDF. You can actually do a data transformation component that knows how to transform text to PDF, and that's what the client side would see. And again, this is all bi-directional, so you'd be able to not just say, I have an application that's expecting to open up a PDF and display it, and really what it's working against is a QSAM file that's got nothing but raw text in it. That works that way. It also works the other way. If you're generating a PDF you want to store in the mainframe, you absolutely could go through that same conversion process and store the output as simple text if that's what your needs are. So very, very open-ended approach there. Can be used for nearly anything in terms of data transformation.
Thank you, Vince. And Vince, other questions that we typically get about Lozen are related to security, and we have a question in the chat here regarding security as well. How do you handle authentication and, more importantly, authorizations to the underlying data on ZOS?
Yeah, and that's a great question. And when it comes to, I'll separate it into two. When it comes to authentication, we generally leave control with the mainframe side of the equation. When a connection comes in, there are a handful of different ways that you can associate that access with the mainframe identity. If you've got an investment in something like Kerberos, then absolutely we can use that, and you get to use the same Kerberos principles and identities that you've got set up in the distributed environment directly with the mainframe. We would inherit that ID automatically, and whatever that application does would happen under the identity of whatever it's signed in as from a Kerberos perspective. If you don't have Kerberos, there's a variety of other ways you can do this. You can do it with digital certificates, so you can install a digital certificate on the client side, and the identity associated with that certificate is what's going to be used when a connection comes from that client. You can also do very specific checking. An example would be IBM's style pass tickets. So you can have a user ID and a pass ticket that will authenticate as that connection request comes through. And once you're authenticated, that you could think of it as that session. All of the things you are going to access from that point forward happen under your identity. If you need, if you're in a secure environment and your needs are more minimal than that, you can also do things like network level security. So based on network identity of the client side, you can map that to a specific identity. And in all of the cases I'm talking about, there's a built-in identity mapping function. So for instance, in the case of Kerberos, we'll understand who the client is, but we'll also give you the ability to say, and I don't want to use that identity unchanged. I want to be able to map it to, I don't know, guest or some other identity based on your own requirements there. So you have really a lot of flexibility to control how a client gets associated back to a mainframe identity. So that's the authentication side of it. On the authorization side of it, it's actually a much simpler story. Everything that we do, we're very careful to drive through normal standard ZOS security protocols. So what that means is, if I have an application running natively on ZOS and it opens a VSAM file, that triggers a certain type of security checking. If I take that application and I move it somewhere else and I access the same data, you're going to get exactly the same security checking as you would expect. So you're free to use all of the flexibility, whether you're using IBM's RACF product or Broadcom's ACF2 and Top Secret. I mean, all of the richness of the policies you see there, all the auditing tools, and so on and so forth are available to you to control who gets access to what. And again, we think this is one of the most important features of Lozen, because that data, it's not like we're copying that data to another platform where you're losing control over it. That data never leaves the mainframe, so you can guarantee that all of the access to that data goes through the security policies that mainframe sites tend to have. So all of that control remains with the mainframe administrator. I'll mention very quickly that doesn't negate all of the security and so forth in other operating systems. So if I think of running something in a Windows stack, Windows is going to impose its own security policy on top of that application and control what it can access and so forth. In effect, you're getting really the best of both. You're getting local security on the client side, which is really a function of is it Linux, is it Windows, is it Mac OS, whatever it happens to be, you're going to get all of that security. And then when that request hits the mainframe, you also get mainframe security. So really, it's very, very tightly controlled there. At your option, last thing I'll talk about in security. At your option, you also have full encryption of all of the data on the wire. Again, this can be done in a variety of different ways. Typically, it's done with TLS and digital certificates. It can also be done by GSS functions in a Kerberos environment. But again, it's as tight as you would want it to be. And conversely, if you're just moving data between, let's say, I don't know, two endpoints within your own data center, you may not want all of the overhead of this. You can absolutely achieve that too. You can kind of customize it based on what your needs are. Sorry, Jeannie, long-winded answer.
Well, I was just gonna say, I don't know if our listeners will know, so I'll just mention that Vince is the original author of CA Top Secret, and as you can tell, security is near and dear to his heart, and certainly well accommodated in Lozen. We're going to move a little bit to savings, but there's a question in the chat along this line, Vince, regarding MIPS consumption. So one question, how to measure impacts on CPU/MIPS on threads opened in the mainframe when interaction with Lozen or Zaac happens? Is there special reports for monitoring / watching Lozen/Zaac?
Yeah, that's a great point as well. And again, Lozen, there's no magic here. We run as distinct process on z/OS. Certainly you can use all of the tools and facilities that you would use with any other server kind of process to monitor us. In addition to that, we do generate a bunch of our own statistics. Some of this is available to you in near real time. We maintain, you could think of it as a virtual file of all of the statistics. And you'll be able to see how much data is going through Lozen, how much CPU time we're consuming, and kind of the key performance metrics. We also write that information on an interval basis to SMF. So if you wanted to kind of trend that over time, you're more than free to do that. As I mentioned before, probably one of the most important features of Lozen is that, at least in our testing and work so far, we see an average of about 90% of the MIPS that we use end up dispatched on a specialty engine, on a zip processor, if you have one. So the cost of doing that is very, very low. And again, you have control at the z/OS level so that you can restrict that we only run on zip, or whether our work can spill over onto general purpose engines. So if you're in an environment where every MIP is important and you're trying to count every penny that way, Lozen gives you a lot of flexibility in how you kind of keep most of that work on the specialty engines. Keep in mind also that the kind of things that Lozen tends to be doing tend to not be particularly CPU bound. I mean, in the case of the encryption I described, we're configured so that if you've got IBM's crypto coprocessor hardware configured in the LPAR where we're running, all of that processing is offloaded that way. And again, most of what we do is either file I/O or network I/O. So we're generally not a big consumer of MIPS. Now, certainly if you scale it up to the point where you're doing, I don't know, terabytes and terabytes of data on a regular basis, then these things tend to get important to you. But I think you'd find that there's just not really a lot of concern there, and our early adopters kind of point this out. Back to you, Jeannie.
Oh, can you hear me?
Yeah. Yeah, you were frozen there for a second, but I think you were good.
I think she's frozen again.
Am I frozen?
Now you're
Not.
now you're better.
Okay. Okay, thank you. Thank you for that, Vince. Dusty, moving on to you and Elsa on to the next slide. There's a number of reasons that customers start migrations and then abandon them, but even for customers, Elsa on the next slide, even customers that are not necessarily migrating, they have many of the
Oh,
Dustin, you know, what is your view of these inhibitors and how Lozen and soon Zaac can help customers modernize data access methods, not only for application migrations, but, you know, just trying to get data into data lakes or whatever the business need is?
Yeah, so let's deal with the migration and the modernization piece first. I think, you know, any of us that have been around the mainframe for a while, this has been a long-standing conversation. The mainframe's dead, etc. And there's a long history of failed projects here because they take a lot of time and money, and there haven't been solutions that have ultimately de-risk those projects. And that's one of the things that Lozen really does help do, is de-risk some of that. Some of the things that Vince has talked about around really how we can decouple the data risk and migration from the application migration. So you can have earlier time to success if that is one part of your strategy. Also, you know, Steve and Vince also touched on this, right? If you have shared data between your mainframe applications and a distributed application or environment, that's a real challenge, and those change data capture routines are extremely complex, expensive to implement, and you know, we hear from customer after customer that often don't work or really have the results that they really need to have that. So Lozen and Zaac will help de-risk some of that by really having a no-code solution, again, to decouple that data and bring some successes, or, you know, solve some of those problems that just weren't available in the market today.
Thank you, Dusty. Can you tell us quickly on the next slide how Lozen is priced just in the last, you know, minute here?
Yeah, I'll just kind of summarize this. You know, we publish our pricing, a little unusual for an enterprise software company. So the first terabyte is $150,000 per year, and then we kind of add terabytes on top of that, as well as the integrations, those connectors that Vince talked through. Those are just $50,000 per year. There's no limitation to those. And overall, we don't limit the number of sites or CPUs or anything. We really want you to be able to use this and have a simple metric to measure what your licensing is. And we can help study that during an eval, like Vince said, through that SMF data or that real-time reporting that Lozen does for you to make sure we get the right fit and the right volume and the right, honestly, return on investment with Lozen. We will find that for you because we want this to be the solution that really you're looking for and has not really been available in the market, and give you some returns on your investment, whatever that challenge is, right? Eliminating change data capture, etc.
Thank you. I guess on the last slide, before we close, Vince, are there any key points you'd like to make relative to the difference between modern data access methods and legacy data access methods?
Yeah, well, I mean, the key differentiators of what you see in the benefits column here, I won't spend a lot of time on them individually, but you know, it really comes down to the fact that it's real-time read write and you know, the type of thing that you can do in a zero code way. You don't have to, you know, sit down and design APIs to your data. You don't have to figure out how to coordinate updates. You don't have to figure out how to do file transfers and scheduling updates, and right, all of that just goes away with Lozen. It's a much simpler approach to data sharing than some of the legacy things that have been done in the past. So I think the you add into that the number of integrations that we've done, the application stacks from Micro Focus and Logic Apps and MuleSoft and all of that, and we think we're getting pretty close to our goal of making it drop dead simple to get to mainframe data, no matter what kind of application you got. And I think that's really the key. It always has seemed to me that the mainframe has been kind of a second-class citizen that way. I can get to all sorts of data from, let's say Linux or Windows, but it's always been hard on the mainframe. We think we're making big steps in kind of leveling that playing field and letting you do these things without having to go through writing custom code and maintaining it, and all of the other things that we've talked about. So I think those are the central points. And again, I'm happy to have a in-depth discussion with anybody on the call as we go, if you want to probe that in more detail.
Thank you, Vince. First of all, thanks to all of you who joined us today, and special thanks, Ashish, Steve, Vince, and Dusty, for sharing your expertise and insights with us today. After the call, we will send to everybody who registered a copy of the presentation, a copy of the recording. I can refer you to our blog, where we have blogs on pretty much everything we discussed today, the integrations, latency, the performance testing results that Vince mentioned, security. There's detailed blogs on each of those important topics. But if you'd like to learn more, please reach out to us directly at any time. And thank you for joining us. We hope you found the conversation lively and informative and well worth your time. We look forward to continuing the discussions offline. Thank you so much. Have a great day, everybody.
Thank you. Bye.
Thank you.
Okay.